In any CFD project, the very first step should be to define the goals. It's very important to know what information you hope to gain by doing the simulation. For instance, maybe it's the pressure drop or the mass flow rate, and also how the information will be used. Once that's been decided, next you want to evaluate modeling options, and this includes, for instance, determining what simplifying assumptions you can make, like using symmetry boundaries or periodic boundaries, what simplifications maybe you have to make because some information might be missing or because of computational resources, and what physical models need to be included, such as turbulence models or combustion models. It's also important to consider what degree of accuracy is required and how quickly the results are needed, because these all tie back to the modeling options that you need to choose. And above all, you want to make sure that CFD is an appropriate tool. There can be instances where there might be other or better ways to get the information that you're looking for. The bottom line is to avoid going into a project thinking that, oh well, I'll just calculate the flow and then later on I'll decide what to do with the results. Having clear goals from the outset is one key to a successful CFD project. Most CFD simulations are performed on a domain that's only one piece of a larger system. It's often not possible to simulate the entire system as opposed to the part that's of greatest of interest to you, and sometimes not even beneficial. For instance, in the graphic on the right, if the goal you decided on the previous slide was to determine the separation efficiency of the cyclone, then you'll gain nothing by simulating all of the piping leading into and out of the separator. So what you'll do is you'll isolate and eventually mesh just the domain of interest for the CFD simulation. Once you decide what piece of the system will be modeled, then you have to choose the boundaries of the computational domain. The selection that you make here is mainly determined by what information you have at the locations of the boundaries. Boundaries should be located where you know enough about the flow to provide the boundary conditions using the available boundary condition types. Where there might be uncertainty, for instance, maybe you know an average value at a particular location but not the detailed profile, sometimes it can be necessary to extend the domain boundaries further upstream so that the information that you have is a reasonable approximation. Finally, always consider whether the problem can be simplified as a two-dimensional or axisymmetric problem. When this is the case, you can get just as valuable information, but it will only take a fraction of the time needed for a full 3D problem.